Hello students, welcome to this video lecture on three-dimensional geometry. In this lecture, as I promised in the previous lecture, we are going to study intercept form of a plane. So it is somehow analogous to the intercept form of a line in a plane. Similarly, we study intercept form of a plane in a space. So suppose we have these three axes given to us, x, y and z, and a plane is there which is intercepting all these axes at some point. Suppose x axis it is a comma 0 again. For y axis it is intercepting at p, and for z axis it is intercepting at c. So we have these three intercepts available to us. Now if we want to find the equation of the plane by the help of this, so one method is basically, as we studied in the previous lecture, we have three non-collinear points which are lying on the plane. So using that concept, we remember we studied a determinant equal to 0, and just see the previous lecture. We will substitute x1 as a, y1 as 0, z1 as 0. So x minus a, y and z. Now x2 minus x1, that will be minus a, y2 minus y1 is b, and z2 minus z1 is 0. Now we will talk about the vector ca. So it is 0 minus a, and 0 minus 0, and c minus 0. So this is how we can write the equation of a plane. Now let us simplify it. So when we will simplify, x minus a is multiplied with bc. So bc into x minus a we have. This is minus y, and we are getting minus ac minus 0. So plus acy. We know the expansion of determinant, of course. Z, this is 0 plus ab. So ab, z is equal to 0. Now if we divide the left hand side and the right hand side by abc, so BC will cancel, you will get x by a, and here ABC will be cancelled and you will get 1. Here AC will be cancelled and you get B, and here AB will be cancelled and you get C. So we are dividing by ABC on the left hand side as well as on the right hand side. So finally the equation of the plane in intersect form is available to us, and it is written like this, and this is analogous to equation of a line in a plane. So the x-intercept is in the denominator of x, y-intercept in the denominator of y, and z-intercept in the denominator of z, of course. Now I'm talking about angles between two planes. So we have studied different forms of the planes till now. So if we have been given two planes, can we find the angle between the planes? So suppose there is a plane like this and there is a plane like this, and this is the line where they are getting intersected. So there will be a normal here, and there will be a normal of this plane also. So if we write the equation of this plane, a1x plus b1y plus c1z plus d1 is equal to 0. So this is the first plane. Second plane is a2x plus b2y plus c2z plus d2 is equal to 0. So the angle between the planes is same as the angle between their normals. And what are the direction cosines of the normals? So this is normal 1, this is normal 2. And if we talk about direction cosines or direction ratios also we can take. So direction ratios of n1 is actually the coefficient of x, y and z that we studied in earlier lectures. So a1 I cap plus b1 j cap plus c1 k cap is a normal vector to the first plane. If we talk about the normal vector to this plane, second plane, so this will be a2 I cap plus b2 j cap plus c2 k cap. Now as we know that the angle between the planes is same as angle between the normals, okay, because if I take this blackboard as a plane, I'm putting my hand here like this. This is another plane. Suppose like this it is here. So the angle between these two planes actually is also the angle between the normal which is coming out of my hand perpendicularly and the normal which is coming out of this board. So actually these two normals make some angle which is also the angle between the planes, because normals are 90 degree, both the normals are 90 degree. So we have added 90 degree to the original angle to both of them. So difference will be still same, 90 degree will get cancelled. So cos of theta, the angle between the normals, you know how to find the angle between two normals. We studied in earlier lectures also. That is the dot product of these two vectors upon magnitude of this vector into magnitude of this vector. So we can write it as a1 a2 plus b1 b2 plus c1 c2 after taking the dot product component wise, and the magnitude over here is sigma of a1 square under root, which means a1 square plus b1 square plus c1 square, and here root over sigma of a2 square, which means a2 square plus b2 square plus c2 square. So this is how we can find the angle between two planes. This is the angle which we will get. If we get a positive value, that means we are talking about the acute angle. If we get a negative value, then it means obtuse value, obtuse angle. So both angles will be there. One will be obtuse, one will be acute. And if they are perpendicular, suppose these two planes are perpendicular planes, theta is 90 degree. So in that case, cos of 90 will be 0, and the special condition will be a1 a2 plus b1 b2 plus c1 c2 will be equal to 0. If the angle between them is 0 degree, that means the planes are actually parallel. In that situation, we know that if there are parallel normals on the two planes, then their direction ratios are proportional. So we can say a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So these are two special cases when the planes are perpendicular or when the planes are parallel. Let us give you one question here so that you can apply this formula. So there are two planes given to us, and those two planes are having equation. First one is having 2x minus y plus z is equal to 11. This is the equation of the first plane. Another one is x plus y plus 2z is equal to 3. So if we find the angle between these planes, cos theta, so a1 is 2 and a2 is 1. 2 into 1 plus b1 is minus 1 and b2 is 1 plus c1 is 1 and c2 is 2. So a1 a2 plus b1 b2 plus c1 c2 by root over a1 square is 4, b1 square will be 1 and c1 square will also be 1. What about this term? Root over 1 plus 4 here also. So you will get root over 6 into root over 6, which will be 6. And here 2 minus 1 is 1 and 1 plus 2 is 3. So 3 upon 6, which is half. So what is the value of theta now? Therefore theta is equal to pi by 3, that is 60 degree. The angles which planes make with each other is 60 degree. And if we talk about the obtuse angle, then that will be pi minus pi by 3. That will be 2 pi by 3, whose answer will be minus half. So both possibilities are there. Whenever it is given find the angle, we generally find the acute angle. Otherwise, obtuse angle can also be obtained by taking negative sign. If I give you a question, and we will discuss it in the next class, next lecture, that as we studied the intercept form in this lecture first, so can you tell me a plane which is parallel to xz plane, a plane which is parallel to xz plane, what will be its equation? We have studied the intercept form, and you can use that intercept form to apply it. Thank you, students.